Hello, space and science enthusiasts. Today we are going to share with you an extremely interesting and exciting discovery from the depths of the universe. An exoplanet, a planet outside our solar system, is undergoing an extraordinary transformation. Let's discover the secrets of this mysterious and strange planet together. Astronomers have detected an exoplanet called TIC-24, 12495330b, located 998 light-years away and discovered by the TESS satellite in January 2020. In addition to having an unusual orbit, this planet is in the process of transforming into a planet known as hot Jupiter. Hot Jupiters are giant gas planets that orbit very close to their star, making a full revolution in just 10 days or less. This proximity makes them extremely hot. However, TIC-2 41249530b is not yet a full hot Jupiter, but may be in the early stages of this transformation. The formation and evolution of hot Jupiters has long been a topic of research for astronomers. The fact that these planets are so close to their stars raises many questions about how they formed and how they got there. Hot Jupiters are gas giants and are exposed to very high temperatures due to their proximity to their stars. This can cause interesting and unexpected changes in their atmospheres and structures. Most hot Jupiters have very short orbital periods due to their proximity to their stars. For example, most hot Jupiters complete their orbits in less than 10 days. The orbit of TIC-24 1249530b is one of the strangest orbits ever discovered. The planet orbits its star at a distance of about 12% of the Earth-Sun distance and completes this orbit in just 15.2 days. However, the planet's orbit is highly elliptical, meaning it is very flattened and elongated. This elliptical orbit causes the planet to come very close to its star and then move away again. Because the planet's orbit is so elliptical, it is subject to large temperature fluctuations as it approaches its star. These temperature fluctuations can lead to dramatic changes in the planet's atmosphere and surface. For example, when the planet gets very close to its star, its surface temperature can rise high enough to melt lead. But at distant points in its orbit, the planet's temperature can be similar to a mild summer day on Earth. Such dramatic temperature fluctuations can cause the planet's atmosphere and surface to have a complex and dynamic structure. What's even more interesting is that this planet is rotating in the opposite direction to the rotation of its star, retrograde motion. This gives scientists important clues about how the planet formed and evolved. Retrograde motion is a rare phenomenon that is not observed on most planets. This type of motion could be the result of complex dynamical processes that the planet has experienced in the past. For example, the planet's retrograde motion could be the result of close transits or collisions with another large planet or star in the past. Retrograde motion means that the planet rotates in the opposite direction to the direction of rotation of its star. This type of motion indicates that interesting and complex events have taken place in the planet's dynamic history. Retrograde motion is the result of dynamic processes and interactions that the planet has experienced during its orbital evolution. This type of motion provides important clues about how the planet's orbit has changed and evolved over time. As TIC-2 41249530b approaches its star, it will gradually become more and more rounded due to the loss of energy in its orbit, and will be pulled into a closer orbit. Once this process is complete, the planet will be much closer to its star and will complete its orbit in less than 10 days. This will mean that the planet will literally turn into a hot Jupiter. This transformation process is characterized by the increasing proximity of the planet to its star and the rounding of its orbit. The gravitational pull of the star takes up the planet's orbital energy, causing its orbit to become even more rounded and the planet to move closer to its star. This process provides an important model for understanding the complexity and evolution of planetary orbital dynamics. The completion of this transformation process allows the planet to be classified as a hot Jupiter. The researchers confirm these remarkable properties of the planet using the WIN 3.5-meter telescope at Kitt Peak National Observatory. Thanks to the NESI and NEED spectrographic instruments, They determined that the planet is about 5 times the mass of Jupiter and has a highly elliptical orbit. Nessie provided a clearer image of the planet by removing the pulsation patterns caused by Earth's atmosphere. This allowed us to more accurately determine the planet's orbital properties. The Need spectrograph, on the other hand, measured the planet's orbital motions and shifts in the star's light spectrum to more precisely determine the planet's mass and orbit. Thanks to these tools, we were able to obtain more detailed information about the planet's orbital dynamics and physical properties. Using this data, researchers can make more precise predictions about the planet's evolution and future transformation process. Future research will allow us to learn more about the formation and evolution of such planets. This discovery is an important step for scientists to understand how hot Jupiters form. Previously, a similar hot Jupiter precursor, HD 80606b, was discovered. These planets provide strong evidence for how high-mass gas giants turn into hot Jupiters. HD 80606b was discovered in 2001 and was considered one of the planets with the highest eccentricity known so far. However, the discovery of Tyche 2.4.124953.0b has allowed us to learn more about the evolution of such planets. These planets help us understand how high-mass gas giants change their proximity to their stars and the dynamics of this process. The research team plans to use the James Webb Space Telescope to study Tyche 2.4.124953.0b more closely. This telescope will help us understand the dynamics of the planet's atmosphere and how it responds to rapid heating. The James Webb Space Telescope is designed to study the atmospheres of planets and determine their chemical composition. This telescope detects molecules and elements in the atmospheres of planets, allowing us to understand their physical and chemical properties. Tyche 2.4.124953.0b's atmosphere can be highly dynamic due to its rapid heating and cooling cycles. By studying this dynamic atmosphere, the James Webb Space Telescope will allow us to learn more about the planet's evolution and transformation. In addition, by monitoring temperature variations on the planet's surface and in its atmosphere, the telescope can learn more about its physical and chemical structure. What do you think about this discovery? How do you think Tyche 2.4.124953.0b's transformation into a hot Jupiter will proceed? What clues does this discovery offer about the evolution of other planets? Don't forget to share your comments with us. These discoveries allow us to learn more about the evolution and orbital dynamics of planets. Planets like Tyche 2.4.124953.0b reveal once again how mysterious and diverse the universe is. Let us know what you think about these interesting discoveries in the comments, and don't forget to subscribe to our channel for more space and science content. Stay in space, stay in science, in